During Oscars in 2014, Ellen DeGeneres took a spontaneous selfie and tweeted it out. Within minutes, the tweet went viral, amassing around 2 million retweets in around 2 hours. And then something unexpected happened. Twitter crashed. For over 20 minutes, millions of users were unable to access their platform. Why? Because the sheer spike in their traffic overwhelmed their systems. And this brings us to a crucial question. How do you design a system that can handle these massive surges in demand? Whether it's millions of users retweeting a celebrity photo or thousands of customers flocking to your platform during a Black Friday sale, the answer lies in scaling. Hello world, my name is Monis, and in today's video, we are going to break down horizontal and vertical scaling, two key strategies for making systems robust and scalable. So if you're preparing for a system design interview or looking to level up as a software architect, this is the kind of knowledge that will set you apart. So let's dive in and learn how to scale systems like a pro. Before we talk about how to scale, let's try to understand what scaling is and why is it important. In simple words, scaling is adapting your system to handle an increased amount of load. Every server where your application runs has a capacity of how much load it can handle. There are different ways of measuring it, but one of the most common one is RPS, that is requests per second, which means how many requests a server can handle in a second. This depends on multiple factors, some of the most important ones being the RAM, which is the size of the server's memory, the CPU, which includes the number of cores, clock speed, and overall processing power, and then the complexity of the code which is executed in each request. For instance, a request to simply load a user's profile is more of a lightweight operation compared to a request for creating a user's profile. There is a process to find out the approximate RPS of your servers through performance testing, which I'll explain in another video, but for now, let's assume that you have a server which has 4 GB of RAM, dual-core Intel processor with a clock speed of 3.3 GHz, which is a simple configuration of a medium-sized server on AWS. After some performance testing, you found that your server can handle almost 20 requests per second. That is roughly 1.7 million requests in a day. Now, let's say that your application becomes quite popular and more people start to use your system. Soon, your system reaches a demand of 30 RPS or 2.5 million requests in a day. Now, this is way beyond your system's capacity. So what happens next? Your system will start to drop requests. It will become slower. And if this traffic demand continues, it will eventually crash. These kind of traffic surges are incredibly common. Think about an e-commerce website during Black Friday sales or a ticket booking platform during the release of concert tickets for a global superstar. So how do we prepare for this? The solution lies in scaling, which is adapting your system to meet the growing demand. So let's start first with vertical scaling. Imagine that you run a package delivery service and rent a truck every day to deliver packages. Let's say that the truck has a capacity of 200 packages. On an average day, the demand is manageable. Your packages comfortably fit within the truck's limit. But what happens when the demand increases and you suddenly have 300 packages to deliver? Obviously, all of them won't fit in the same truck. One way to handle this is to rent a bigger truck, one that can carry 300 packages in a single trip. Now, let's connect this analogy back to the system design. In this scenario, the truck is your server and the packages are the user requests. So when your existing server can no longer handle the growing load, one straightforward solution is to upgrade to a more powerful server, one with more RAM, a faster CPU, or probably both. For example, if you're running your application on a server with 4 GB of RAM and a dual-core processor, and you're seeing consistent demand beyond its capacity, you could replace it with a server that has 8 GB of RAM and a quad-core processor. Theoretically, this upgrade would double your server's capacity, allowing it to handle 40 requests per second instead of 20. This would accommodate your current traffic of 30 requests per second with even room to spare. This approach, where you replace your server with a more powerful one to handle the increased load, is called vertical scaling. Now, this solution sounds quite simple, but it does come with some drawbacks. Just like renting a bigger truck costs more money, upgrading to a more powerful server also comes with a higher price tag. As your demand grows, your costs grow with it. Just like trucks come in fixed sizes, servers also have limits. You can't keep scaling up indefinitely. There is no server with infinite RAM or unlimited number of cores. At some point, you will hit a ceiling. With just one server, you're putting all your eggs in one basket. If the server crashes or experiences an issue, your entire application goes down, leaving your users unable to access the service. To overcome these challenges, we turn to a more flexible and scalable option, horizontal scaling. So let's revisit our delivery service analogy. Instead of renting a bigger truck to handle 300 packages, there is another approach. Rent 2 trucks, each with a capacity of 200 packages. You can split the load between them, with each truck carrying half the packages. Together, they get the job done without the need for a single, larger vehicle. This is the essence of horizontal scaling. Instead of upgrading a single server, you add more servers to share the load. For example, our server with 4 GB of RAM and a dual-core processor was capable of handling 20 RPS. If the traffic spikes to 30 RPS, instead of upgrading to a more powerful instance, you can add another server of the same capacity. Each server can handle a maximum of 20 RPS, so the two servers together can handle 40. Therefore, the traffic demand of 30 RPS is then split between the two servers, allowing them to handle the load comfortably. Horizontal scaling solves the core problem of adapting to the increased load, but it offers additional advantages as well. Unlike vertical scaling, where you eventually hit hardware limits, horizontal scaling allows you to keep adding servers as needed. In addition to this, if one server crashes, the remaining servers can still handle most of the traffic, which prevents your application from becoming completely inaccessible in case of a server failure. Horizontal scaling also gives you flexibility to scale up during peak times, like Black Friday sales, and scale down when the demand normalizes. This approach is often more cost-effective. From the looks of it, horizontal scaling sounds better than vertical scaling, but this approach also has its own challenges. With multiple servers, you need a load balancer to evenly distribute incoming traffic. Without it, some servers might be overwhelmed while others remain underutilized. If you're curious about how load balancers work, check out my other video on load balancers. Another challenge is managing user sessions across multiple servers. If a user logs in on one server, how do you ensure their session persists if the next request is routed to another server? To summarize, with vertical scaling, you're upgrading a single server to handle more requests. However, with horizontal scaling, you're adding more servers to distribute the load. But here's the big question. When faced with a choice between vertical and horizontal scaling, which approach do most organizations take? The answer is both. A hybrid approach combines the strengths of both approaches, but that raises another critical question. Even with the hybrid model and the knowledge of expected load, how do organizations decide how many servers they need and what capacity those servers should have? So let's dive a little bit deeper. When designing a system, mitigating a single point of failure is a critical priority. That makes horizontal scaling almost unavoidable in any robust architecture. But things get more nuanced when we look at real-world configurations. Let's imagine that our application has an expected demand of 60 RPS. To handle this, we have two potential configurations. Option 1 is to deploy 3 servers, each capable of handling 20 RPS. And option 2 is to deploy 2 more powerful servers, each capable of handling 30 RPS. So how do we decide which approach is better? Well, the answer isn't straightforward. It depends on a variety of factors. The first factor is cost. Compare the costs of configurations. More powerful servers can often get expensive, while smaller servers might offer a more cost-effective solution. So compare the costs of both the solution to see which one better fits the pocket. Another point is to understand what each request is doing. If your application handles CPU-intensive tasks like complex computations or video processing, it might benefit from more powerful hardware, making option 2 the better choice. On the other hand, if each request performs lightweight operations like simple database lookups or returning static content, option 1 with more servers at lower individual capacity might be more efficient. More servers generally mean more resilience. With option 1, losing one server still leaves 2 others to handle the traffic. With option 2, losing one server cuts your capacity to half, which can be a serious bottleneck. In essence, scaling isn't a one-size-fits-all solution. The best approach depends on your system's specific requirements, expected traffic, and the trade-offs that you are willing to make. It's about striking the right balance between cost, and performance while keeping the best user experience in mind. And this is exactly what your interviewer will be looking for in the next system design interview: your ability to analyze the problem, weigh the options, and make informed decisions based on the available data. Now, scaling seems quite straightforward. You add more servers, or you add more power, or you do both. But when it comes to scaling databases, things get quite complicated. And that's exactly what we are going to cover in my next video on database scaling. Don't miss that topic, because that's precisely where you're going to get stuck in a system design interview. As always, if you have any questions, drop them in the comments below. See you in the next video. Bis dann.